Hello everyone. So far we have discussed about the electric potential and the electric potential due to several objects. Today we are going to discuss a very important phenomena, and that phenomena is discharging action of sharp points. So before discussing it, we will summarize the previous concept, and that was the potential due to point charge or the potential due to a charge shell. So let us consider that it is a charged shell and that is uniformly charged with charge q. The radius of this shell is r. So we know that the potential on the surface of this cell is given by k times the charge by radius. And if I just wanted to find out the field on its surface, then the field is k times the charge divided by the square. It is the magnitude of the electric field, and remember that the field inside this hollow shell is 0. Now, what if my conductor is not spherical in nature? Because we know that there may be any kind of the conductor. So I am just taking a random kind of conductor like this. If a charge q will be given to this conductor, then we know that the charge resides on the surface of the conductor. So the charge will distribute over its surface. Now, just see the previous one. If I am having a shell, then the charge density that can be calculated by charge divided by the surface area. Since the radius is same, so the charge density will also be same for a spherical shell. But here in that case, since this shape is not spherical, it means the radius is not same everywhere, so the charge density will vary. Or we can also say, as per this potential situation, that if R will vary, the potential will also vary. Now we will focus on our edges just like this one. If it is a curved surface, then a small curved surface can be taken as a part of the sphere. So I am just completing the sphere of which this surface is a part, and if you can see it clearly, the radius of this curved surface is very small. If I will do the same for this surface, then consider this is the section of a sphere. Then if I will complete the sphere, it is going to be a very huge sphere. So its radius is say r2, this radius is r1, and let me take this sharp edge here, and if I will consider a sphere for a small portion, the radius will be much more small. The potential says that if the radius is low, the potential must be very high. So in that case we can say that here the radius is large, so the potential is low here, and here since the radius is very small, so its potential must be very high, and for the potential to be very high, the charge on that surface must be very large. That is, that if you will give a charge on this conductor, the charge will not uniformly distribute. In fact, the charge will accumulate in large amount on the sharp edges, like this, here too, and since the radius is large, so the charge will be less as compared to these sharp points. So if we have a conductor like this, then the charge density here, or you can say the charge at this sharp edge, will be very high. That is the concept behind the discharging action. Now, since the potential at this point or like that point is very high, then it may lead to the isolation, or you can say the electric breakdown of the surrounding air. Now suppose that the potential at this point is very high, it means the that is accumulated at this corner is very high. So near this corner the electric field will be very high and it is ionizing the air around it. So what will happen, you can see it from here, that if this high voltage leads the ionization of air, then on ionization we have a pair of negatively charged and the positively charged ions. Negatively charged ions will attract toward this sharp edge and the positively charged ion will be repelled by this corner. So these negative charge will neutralize the charge, few charge on the corner of this conductor, which is having very high potential at the sharp edge. Since this negative charge will neutralize a part of charge on this corner and the positive ions will be repelled away, then the fresh air will come. Once again the ionization will take place and the process continues. The process by which the charge at the pointed end of a conductor gets discharged is called corona discharge. So this is the concept behind the discharging action on a sharp points. Now, before discussing the working of Van de Graaff generator, we will discuss the concept by which the functioning of Van de Graaff generator takes place, and the process is quite simple. If you take a small hollow sphere here, the radius of hollow sphere is r, and we have a second hollow sphere of radius r, and these two are concentric. Now suppose the outer one sphere contains a charge q and this inner one conducting sphere takes a charge q. Now first of all, I am interested in finding out the potential on the surface of inner cell and the potential on the surface of outer cell. Let me take this point as P dash. So as per previous study, if I wanted the potential on the surface of inner cell, then the potential will be the sum of potential due to its own charge as well as the potential due to the charge of this outer shell. So it is the sum of potential due to its own charge, and that is going to be K times Q by R plus the contribution of potential of this cell, as this point is inside this cell. So the potential will be same as the potential on its surface, and that can be calculated by KQ by capital. It is the net potential on the surface of inner shell. Now the potential on the surface of outer cell will be the potential due to its own charge as well as the contribution of potential due to this inner shell. So I will write it first, the potential of outer cell due to its own charge, and since this point is outside this cell, so the contribution of the potential will be K times the charge divided by charge. Let me call this equation as 1 and this equation as 2. It is very clear from these two equations that these two terms are equal. So V R and this potential in the inner cell and this potential in the outer cell will only depends on the value of this, and it is very clear from these two, since you know that small r is less than capital R, so the potential of the inner cell must be higher than the potential of the outer cell. It means the inner shell has a high potential. Now how much high, or what is the difference of the potential between these two surfaces? I can calculate it here like V small r minus V capital R. So if I will do that, these two terms are equal, and on simplifying we will get K times Q 1 by R minus 1 by R. This is the potential difference between the points on inner cell and the outer cell. Now suppose I am connecting the inner shell to the outer cell with a very light conducting wire. So in that case, since the potential of inner shell is high and the potential of outer cell is low, so the charge will flow from inner cell to the outer cell, and this flow of charge will continue till the potential difference becomes zero. So suppose that these two are connected and the potential becomes equal. So in that case, the difference of potential must be zero. And if we will satisfy this equation here, then this is K times Q 1 by R is 0. The K is constant, a small r and capital R the finite values. So this equation will only satisfy when small q equals to 0. It means the charge on the inner surface is 0. Indirectly means the total charge of the inner cell must go to the outer cell in order to maintain the same potentials on inner cell as well as on the outer cell. That concept is very important, and it tells that whatever amount of the charge you will give to the inner shell, the total charge will flow to the outer cell if you will connect both the cells with the help of a conducting wire. So, we will discuss the construction of 1D Graaff generator. Basically, 1D Graaff generator consists of a large spherical shell supported by an insulating stand, and there are two pulleys P1 and P2 over which a belt of insulating fabric like silk or rubber is made, and these pulleys are governed by an motor. There is a comb near the lower pulley, and that is connected with a high voltage rectifier, and the other end of the comb is grounded. Inside the cell, another comb is C2 that is internally connected to the shell with a wire as it is shown in figure. As we know that 1D graph generator produces a very high potential up to several million volts. So it is used to accelerate the charge particle. So we have a discharge tube in which there are ions, and in the bottom end of that tube there is a target, and the target is grounded to make the potential low. So these are the symbols used in this diagram. Now the working is, if you can see it, this is functioning right now. So since the comb C1 is connected to the positive terminal of high voltage rectifier, so it produces a very high electric wind that is caused by the discharging action, as we have discussed, is also called corona discharging. Now the pulley carries these charge in the upward direction, and the comb C2 is induced with the negative charge which are carried by conduction of inner surface of this sphere through a metallic wire that is shown in the diagram, and induces positive charge on the outer surface of the shell. This process continues for a longer time to store more and more charges on the sphere, and the potential of the sphere increases considerably high. When the charge on the sphere is very high, the leakage of charge due to ionization of surrounding air is also increases. There is a point to remember that maximum potential occurs when the rate of charge carried by the belt is equal to the rate at which charge leaks from the shell due to ionization of air. And that is the basic concept of quantigraph generator. So now we are just going to watch the 1D Graaff generator, and we will also see the discharging action of 1D Graaff generator. So I have switched on my 1D Graaff generator, and this shell is of larger radius. The charge is accumulating over the surface of this large cell. Now, as the charge is accumulating over its surface continuously, so this charge is producing the electric field around it. Now you can see the field of this sphere is attracting the hair of this child, and this is due to the high potential of this cell, or you can see the electric field that is produced by this sphere. This conductor is positively charged, so if I will place here, you can see the discharging action. So the charge is leaking from one sphere to another sphere, and these two spheres are positively charged. This 1D Graaff generator is producing a very high voltage here.